At the other end, the step length can theoretically become so long if they're really running that you simply don't find the second step because it's so far afield. The first step is on a handy road, the next step is in a patch of heather. You just don't find them. I mean, the top end is
Please support this channel by subscribing and leaving comments.
Index, which you can extract out of all these paired measurements against the foot length. And you get this kind of a regression line out of it. Obviously descending, that is, the larger the foot gets, this is in effect the multiplication factor on the left-hand side to height. The smaller the multiplication factor gets. So when you're looking at a 2-foot long footprint, the multiplication factor is at best 5, if not less, and probably at the upper end, I suspect it might swerve to the left. I'm sort of skeptical of those outliers on top, that for embryological reasons or pediatric reasons, you can assume that the smallest footprints in the vicinity of 4 inches probably have a factor of 7 or something like that. 7, perhaps 8, I would think, as a maximum. I suspect the 9 to 10 is spurious. What this means, the implications of this particular graph, is that first of all, foot length does not scale linearly with the height of the creature, but it increases disproportionately. The heel also seems to increase disproportionately with increasing height, and the width increases, but at best at the same rate as the length. So the overall, the foot area, which is very flat, as you well know, increases vastly more than it does in man. And that's presumably a biological function of the weight of the creature that increases enormously. Now, everybody, of course, has estimated over and over with different methodologies about how much they weigh. And much to my, this is another way of graphing that previous curve. So it gets very far into these high height indexes for small feet, which is unreasonable, I believe. Now this is Grover Kranz's extrapolation of weight that includes Jacko, who was weighed at the time under conditions of relatively uncertain health. I mean, it was obviously away from its mother, it was still young, and there's no telling in what health it was at the time. The Patterson Sasquatch is a weight that he extrapolated from the heel width and from simply measurements of cylinders of the creature as a whole. So that's somewhat conjectural. And the upper one, which is listed as simply Kranz, is an apocryphal story that he got of somebody who shot an 8.5-foot Sasquatch and estimated its weight at 850 pounds. But you've got values put together there, all of which are a little questionable, and one hesitates to put all one's eggs in that particular basket. Obviously, it would be nice to have an alternative approach where you could do some hard data. And my digging around in the literature, I came up with, first of all, size and scaling in primate biology. There's a book that seems very pertinent. and a specific article by McMahon on size and shape in biology that was published in 1973, in which he found that the chest circumference is related in a straight line to weight in primates in a double log plot, all the way from a tamarin. I will return to that in a moment. From a tamarin, which is this little mousy, squirrely primate, the red dots are various monkeys getting up higher and higher. This is a baboon, and the next red dot I scaled in the gorilla. I happened to find out the chest circumference of a gorilla in the literature, which also fits the same regression line. And then the black asterisk is the chest circumference of a Sasquatch, which you can extract out of the Patterson movie. It has a 22-inch width to the chest, and if you expand that by something less than pi, I use 2.9 because that seems to work for people, for men at least. You come up with this chest circumference of 64 inches and a weight, which you can read straight off here, of 567 pounds, which is a very reasonable estimate. Other people have estimated it to be 600 pounds. Robert Krantz drifted more around the vicinity of 520 pounds. Now, since this line extends from tamarins to gorillas, there's absolutely no reason why that little extension there to the right shouldn't cover all the Sasquatches. So I've on the assumption that chest circumference, which is a linear measurement, scales directly to height of the Sasquatch, which is a linear measurement, I've expanded that. An 8-foot creature would weigh 706 pounds, give and take 10% each time. 8.5 foot, which is Krantz's 830 pounds, which is pretty close to what that supposed hunter estimated. 9 foot, 904 pounds, 10 foot, 1197 pounds, and 11 feet, 1,558 pounds, give and take 10%. So at least, I didn't expand it to 12 feet. 12 feet would probably be something of the order of 1,900 pounds. It's still a lot better than the absurd estimates of 4,000 or 4,500 pounds that have been made for the really big ones, which would be difficult to defend. Now, returning to the Patterson Sasquatch, at 567 pounds, it happens to be, published by Schmidt-Nielsen in 1970, that there is a straight regression line for basal metabolism for animals, which remains a straight line from mice to elephants. And Sasquatches sit right there in the middle, somewhere in between. And that is shown in the next graph here. Again, extracted out of the literature. The little button there in the middle is the Sasquatch. So you can read off its basal metabolic rate at that 257 kilograms that I've calculated. And its daily basal metabolism rate is 6,000 calories. Now that is basal. If it was dead asleep all day long, 250 kilocalories an hour. If you expand that to an average activity and do not include really inclement weather, you would have to expand that at least to 12,000 calories per day. Even if we didn't know anything else about a Sasquatch, we know that it doesn't have a gigantic gut and sit around all day. If we knew nothing else, we're almost forced to assume it was omnivorous, a folivorous diet, that is the diet of eating mostly leaves that the African great apes primarily follow, along with fruit eating. It's fine if you sit around most of the time, as they do. They don't migrate over long distances. and it's a warm climate, and they're surrounded by an immense variety of vegetation. But if the climate is harsh, as it is around here, it just about has to be supported by fat intake. And from all I've heard over the past years about any analyses of feces, there were always rodent hairs in it. One gets a relatively steady trickle of reports of them taking down deer and that sort of thing. And a plain white-tailed deer liver alone probably has something of the order of 8,000 calories in it. So you can see that it wouldn't be very difficult for them to make a living. Okay, up to now, these have been all the static data. However, you can expand this to the dynamic too, specifically to Gait. Now, first of all, I've taken 228 measurements of pace and graphed them out like that. It is not unreasonable to assume a curve like that, because of course they do shuffle around when they're looking at passing military vehicles or whatever, and so you do have step length down here going down to 0, but that hardly contributes very much. At the other end, the step length can theoretically become so long if they're really running that you simply don't find the second step because it's so far afield. The first step is on a handy road, the next step is in a patch of heather. You just don't find them. I mean, the top end is 12 feet. You'd be hard put to find the next footstep, even if it was a perfect row of 50 steps running through the countryside. You'd simply not be able to retrieve successive steps. And they don't run down freshly plowed lumber roads that commonly, right? Anyway, now if you pit the foot length against the gait and get a regression line out of it, you get this. It's actually there's a lot of information in that. First of all, there's a step length on the left. The scatter is of course large, and that is due to the reason that some people measure step length between the feet, just the open space between left foot and right foot. Some measure it as they ought to from heel to heel. Some measure it from heel to toe of the next foot. And for all I know, there might be some people that measure 2 footsteps. That unfortunately has not been recorded, and people usually are not very specific about it. So I had to throw it all into one pot. However, what emerged in a way surprised me, that the regression line is a very conservative one. The Patterson Sasquatch sits here, just a little bit above the normal resting pace. You can assume that most of the footprints are laid down when the Sasquatch wanders through the countryside minding his own business, neither hurried nor lagging. And what you see here on the floor is the average footprint, the average 16 footprint laid out at the average pace distance. That is the statistical average. The one is a little skewed. While we're at footprints, since there are many people measuring them, people who really specialize on footprints, specifically paleontologists that measure dinosaur footprints, they measure far more than Sasquatch researchers measure, and maybe you ought to take an example from them. For example, they measure the offset of a line that goes through the right feet from the offset of the line that goes through the left feet. If we had this, and I don't think we have it, you'd be able to make some inferences around hip insertion, how far the legs are apart. They tend to be a fairly narrow line, which tells you by implications that they have a pretty narrow hip. The other thing that they measure is the angulation. That is, you take 3 points on successive footprints between, let's say, right heel, right heel, and draw a triangle and find out what angle is subscribed by the one foot that sits in between. So you can describe the gait much more extensively. I recently got a personal report of a long line of footprints that went in the snow that were precisely measured as I wish that they were measured. It took them a full day to measure, to follow the track. Nice sunny day. They got sunburned too. The plain gait, the creature came out of a deep canyon near Mount Hood, walked then along a lumber road, totally snow-covered and unused for a good 3 miles, and then returned to the same canyon, as if it had made a shortcut over easier terrain, which, by the way, to some degree puts a lie to the supposition that they like to hide their footprints. They like to walk on a plain road just as much as any other hiker likes to walk once in a while. The plain gait on the road fell dead center onto this regression line. It was a 16-inch footprint, I believe, at 57.5 inches. When it went up a steep slope, he estimated it at 30 degrees, the gait dropped to 52 inches, which is a remarkably small change. In other words, a lot of power behind it. Also, he added that as it was walking steeply uphill, there was no standing around, catching its breath, stopping for a snack, none of that. It was machine-like precision uphill, and when it went down the same slope, its step lengthened to 67 inches. So just a long step as mountaineers do when they charge down, let's say, a gravel slope. By the way, the mean footprint length, the mean step length here is 58 inches. That's the average, and it ranges from 2 feet to 12 feet. Now, somewhere along here, of course, the legs of even the largest Sasquatch aren't long enough to alternate on the ground. In other words, it changes its gait from walking to running. Where that occurs, theoretically, there should be good biological laws to apply. For four-footed creatures, there are. The change from trot to gallop, for all sorts of assorted features are available as nice curves of family that have a break where the change in gait occurs. Such apparently is not available for people, unfortunately. We don't have any other bipedal examples to model out after. I don't think that you'd want to use penguins, let's say. Now, the speed that is inserted on the right-hand side is extrapolated from the Patterson Sasquatch, on which it can be calculated, assuming it was filmed at 16 frames a second. What I have gotten assured time and time again that 24 frames per second original filming speed is out of the question. That what you see on TV, however, usually is shown at 24 frames a second, and it sort of goes like that. If you run it actually at 16 frames a second, it's a heavy but stately gait, something of this nature. Even at that slow gait, it's walking at 4.8 miles an hour. That is sort of the hinge point for the extrapolation of speed. Now, I've extrapolated the walking speed by maintaining the same cadence of walk for the bigger Sasquatches above it, which is of course dubious because as the leg goes longer, it has a lower pendulum swing. But what that mostly would produce, if one corrected for that and had some input to know how to correct it, is that the scale on the right would contract a little bit about the 5 mile an hour value. The top would come down a little, the bottom would come up. I suspect that the running, there's a scratch in the middle that was on the slide. The horizontal line is of no importance. The blue line is a very rough estimate of where it might be changing from walking to running. But I suspect that once I find some hard data to plug into that, where people change from walking to running, that might occur much lower, like about at this level. Because, for example, the Olympic walkers that have this very artificial fast walk, that is very unnatural, it's very energy inefficient. That is the peculiar thing is that a creature that is human beings running increase in efficiency in conversion of metabolic energy to mechanical energy when they go from, let's say, starting at 4 miles an hour to 12 miles an hour. It's a rather steep increase from 30% conversion efficiency to something like 70% conversion efficiency, which is rather amazing. I mean, any engineer would be happy to get that sort of efficiency out of their engines. So this will take some time. The line that I indicated is predicated on approximately changing to running when your step length exceeds 1¼ times your normal rest length, which may or may not apply to Sasquatch. And I think it may be more reasonable by experiments that I do with myself. If you go 20% above your normal pace in speed or length, that you have to start running. It's more efficient in any case. Now, the last thing, of course, with working through all these data is the last remnant. What we really don't know at all is how old are all these creatures? What are we looking at? So, since I had a lot of data at hand and was looking at, let's say, gorilla growth, here you have some perfectly nice curves for male and female gorillas, I decided, well, I ought to be able to do the same thing for Sasquatches. Now, this is what resulted. I have to tell you what went into it. First of all, the smallest walking footprints that have been observed are 4 feet 4 inches long. People walk it about a year. Gorillas locomote about, I mean, they don't walk on 2 feet, but about in half that time. Human feet are about 3 inches long at birth. Gorilla feet are about 3 3/4 inches long at birth. Gorilla feet obviously still are have much more the anatomy of an arboreal animal, whereas the Sasquatch foot has truly left its arboreal ancestry behind. So, as a rough estimate, just as a point to argue from, I've assumed that the 4-inch footprint corresponds to an age of a year, and probably on the safe side. They might already have a bigger foot at a year. Then, secondly, I got a report of these values, 3 footprint measurements made over the course of 7.5 years with precise dates on them, that the person was fairly certain were all of the same animal. So I plotted those out first to their time base and slid them into place to match up with a 4-inch at 1 year. Then you have to find out when do they stop growing. We really don't know that, but I went by the assumption that any female that has a baby with it is going to stop growing, if not only for the hormonal maturational effects that take place when you're pregnant, but also the calcium drain that the growth of the fetus and the subsequent protracted nursing would be on the mother. That it's a reasonable assumption that the mother is not going to grow a heck of a lot more. Now, whether a set of footprints in mother and baby, of course, means that you have to have a very small one that still is a baby, and a big one to accompany it. And there's a very small choice, but I did find a set that ranged between 13 inches of foot length, which is plotted on the left, and about 15 and a half, 16 inches, or a little bit more on the uppermost values. These are all footprint sets where one creature had a footprint of 4, 5, 6 inches, was just a few years old, virtually a toddler, infant, and the other footprint was large. It's unreasonable to assume that a very small baby wanders around just with a sibling, and even less reasonable to assume that it walks about with a male. So I would offer this as the first guess at a growth curve for Sasquatch females, maturing at approximately age 18, and probably having their first infant somewhere around age 11 or 12. Basically, the timing is somewhat reminiscent of the maturation of gorillas, which is not unreasonable because science there goes hand in hand. Now, what can you make out of all of this? First of all, you can start thinking what you might want to do with it. The maximum speed, walking and running and all that has a relation to energetics. It has a relation to the home range and possible migration distances or migration distances overnight. The caloric intake has immediate implications about how they forage, where, when, and the social structure among primates for foraging. Because if a particular available food is not very plentiful, primates generally, even if they are slightly socially organized, generally break up into individuals to forage for themselves, because if they find one patch of berries, that's fine for one animal, but it would last for 3 minutes for a small fruit. And such groups then maintain in contact with one another through long-distance communication, presumably screaming. Overall, of course, at worst, these results are off, but they're not going to be off by a large fraction, and certainly not by an order of magnitude or anything of that nature. We do have definitely a need for corroborating evidence. For example, the exploration of foot pressure for a given size foot as indicated by indentation in the ground. I still think that a case could be made for devising a suitable gadget that mimics that. The family association, all the paired or multiple footprints should be examined with an eye to what combination of adults and infants they might represent. And of course, above all, it'd be nice to have some baby data. Well, any of it is open to falsification in the sense of scientific research, but obviously the falsification will have to take place by new data, on new hypotheses, and not by attack on the collectors of these data. And I have given the entire talk in the dark, and I hope I've left you less so.
We have an opportunity for questions now.
That's a quick question.
Yes.
On some of the statistical data where you were plotting what you called indices, width or to length,
Yeah.
where there was a lot of noise.
Yeah.
Look at any of that in the similar log-log fashion?
Well, the log is appropriate if you are comparing, let's say, a linear measurement to a mass measurement because they are related in a log fashion. But when you're comparing two linear measurements like foot length and foot width, there's no logical reason to compare it to in a log fashion. All you're doing is compressing the data. Everything looks like it falls on a dead straight line, and it gives you false security that it's true. I rather stick with the straight data because it gives you a more visual impression of really what noise is involved in it. Yes?
You were saying somebody found some footprints in snow, but you didn't say how long the tracks were.
About 3 miles.
No, I mean the foot itself.
Big Sasquatch.
The foot itself. The length of,
16 inch.
how much?
16
Where was that?
in Oregon.
Where in Oregon?
Mount Hood.
Who investigated it?
Pardon me?
Who investigated it?
I did.
How come you didn't show us the slides?
I'm a lab scientist.
You what?
I'm a lab scientist.
You really didn't take pictures of them?
I didn't know. By that time the snow was gone. Well, you know, no, neither did anybody else of the other 300 tracks that went into this graph, so I don't see why any given one track should be any different. You either rely on somebody's
You don't rely on
integrity.
anybody.
Okay, then the Sasquatches probably should be ranked with this unicorn.
No, but you
Because
know,
it's all hearsay. It's
nowadays we should just gather more material, photos, measurements, all
the
that.
measurements I got. Yes?
Questions?
Yes.
Yes. What do you think about Kranz's theory of it being the social structure of the Sasquatch is probably a harem type setup like mountain gorillas?
Mountain gorillas are very heavily social,
Yeah.
and they hang together. The environment is conducive to that. There are, after all, something like 5% of the findings that involve multiple footprints at the same time, which isn't a heck of a lot. Oh, one thing I neglected to say, this entire footprint database is still open to one objection, which nobody has figured out yet, namely, if the females and infants preferably stay in the bush, completely away from people, the footprint histogram is going to be very heavily biased by male footprints. And it's going to be shifted to the right, and that might, of course, also account for the fact that there's not much of a hint of an effect of a double distribution, sexual dimorphism. We can't know that. I have yet, even Grover Krantz, I don't think, can tell a male from a female footprint.
But he does in his book about 50 times. Yeah, he
Well,
does.
if you see the creature with it, that's fine. I mean, we know that for the Patterson creature, but we hardly know it for anybody else. So we have to operate on a sexless Sasquatch.
Questions?
Yes.
You mentioned something about extrapolating the age of the females with the height and things, because were there apparently two sets of tracks of the regular 16-inch type track and a smaller track that were together? Is that what that...
What, the curve?
Yeah, the curve.
No, the curve is simply a growth curve.
But I mean, you mentioned smaller tracks, like if they were from a child or something.
Yes, right.
Were there tracks that were found?
Yes, oh
large
yes,
tracks
there
with
are a
small
goodly
tracks?
number of tracks where they were evidently mother and child. In fact, there are tracks where the child was carried most of the time and then sat down on the ground and made a few little tracks and picked up again and carried on. That's the sort of records that I've used, yes.
You compared the track, that size with the age. Have you ever gone so far as to try to determine mortality?
There are so-called scaling formulae, which are power formulae that relate weight of the creature to presumptive age. There are there are such scaling power formulae to relate the onset of reproductive maturity, length of life, and all sorts of features like that if you know the weight of the creature. I do have those formulae. I only came up with that chest circumference business relatively recently, so I haven't expanded it into all the nooks and crannies of logic that I can carry it to, if any.
Is there an estimated maximum age?
By size, I suppose you would guess at 35, 40 years. Yes.
You know, we haven't touched on the hairs that have been sent in for analysis in Ohio State. You might explain to the people the little background on those hairs.
I don't know that this hair business has appeared on the internet, and I've contributed some of it too, but not necessarily to anybody else. I do have a few hair slides here. First of all, to give you an idea of where okay, I'll show you a few of these slides. These are human, this is a little batch of human hair. What I want you to see on that as a warning about lip identification of hair, that this comes off one single creature, namely me. Some of the hair has a thick core of a medulla. Some of it has an occasionally interrupted medulla. Some of it has a so-called fragmentary medulla, which is supposedly the hallmark of primate hair. And some hair has no medulla at all, that skinny one. If you keep going through different hairs, you on the same body, in areas that I won't necessarily mention, you get wild-looking hairs like that you might at first sight attribute to bear, or hairs like that it would be anybody's guess. Very solid, gigantic, continuous medulla inside it. Some with pigment, some with slight pigment, some without, and so forth. So I have looked at hair for approximately 30 years, which started with some purported Yeti hair sent to the Primate Center from Nepal that long ago. And the last hair I looked at was not more than a week ago from a supposed Sasquatch sighting, and it was squirrel. Once I find that, I don't go into the species of squirrel. Now, since people don't know, probably all of you, the story of this hair that's undergoing analysis, I probably should relate that, because it entails our old friend Paul Freeman, and everybody is down on him. However, if his hair pans out, you're all going to be eating crow. You better
I'm not.
hedge your bets both ways. Okay, what happened that this last August, some bow hunters, the bow hunting season just opened, saw a lot of tracks on a road in the Blue Mountains, east of 25 miles east of Walla Walla, and told Paul Freeman. He that evening notified Wes Summerlin and Bill Lowry to come with him up into that area the next morning. They arrived there at about 8 o'clock and found the tracks and started tracking them into the forest. After there were 3 sets of tracks, incidentally. One pretty big and one medium and one smallish. After a relatively short distance, they encountered 3 freshly twisted off trees. They were twisted off recently enough that the cambium was still bleeding. 2 of these trees had big batches of hair caught in them, which they providentially collected and ultimately sent a good set of it to me. After they collected that hair, they sort of split up, Paul Freeman going in one direction, the other 2 going the other direction. And a little farther along, West Summerlin said they started smelling the typical Sasquatch smell. And still a little bit beyond that, they found incidentally along the ground little plants that I identified ultimately as yellow violets had been picked off. They're just a little stem with some leaves on top. They had eaten the stems and thrown the leaves away, which is a very finicky eating behavior. Presumably the stems sort of taste good, or they had medicinal value for all we know. A little farther along, Bill Lowry stopped and saw something standing in the forest, and he had 6x28 binoculars on him. Then he looked at it, and it was a tawny Sasquatch standing stock still in the forest, superbly camouflaged, he said. He could look at it from head to toe. It did not have breasts. It was presumably a juvenile. It was between 6 and 7 feet tall, standing stock still. And then as West Summerlin stepped alongside him, the creature abruptly and silently moved away. They tracked it for a little while and couldn't hear anything, so everybody sat down and everything was quiet. And I forget the exact sequence of the events, whether one of the Sasquatches screamed first, or whether one of the men yelled to the others, "Where are you?" Anyway, the moment they yelled, all hell broke loose and the creatures crashed through the thicket and crossed the road into the Mill Creek watershed area that they evidently came out of, which is off limits to human travel. The hare came to me and asked, this is what it looked like. In effect, human hair, appearing human, different coloration, and different length. There was one batch which was tawny colored, an average of 4 inches long, every hair with a root on it. So it was hair in the anagen stage. Every hair was in the anagen stage, meaning it was actively growing. The second batch was much more darkly colored, had the identical microscopic anatomy, had an average length of 8 inches up to 15 inches long, and was very dark brown to black colored. The hair could be human or Sasquatch. That are the two options. A remote option is cow. There were no cows in the area, but in addition, this hair has split ends, which is the hallmark of primate hair, and cow hairs come to a tapered point when they're worn. So, to settle that problem, whether it is human or Sasquatch hair, the only absolute choice we have is mitochondrial DNA sequencing. So I bestirred myself and phoned various DNA labs that might be interested in doing this sort of thing. Well, most of them do not have the experience with hair. Others are federally financed labs that are precluded from working on mythological animals. Other people simply do not want to touch it. But fortunately, there is Dr. Poirier, who is the chairman of anthropology at Ohio State University, who has published a couple of papers on the Chinese wild man and has made some expeditions over there, who I heard was interested in hair. So I phoned him and found that he is affiliated with a Dr. First in the Department of Molecular Genetics at Ohio State University, where they in fact try to specialize on mitochondrial DNA sequencing of hair. So I sent it to them. They started working on it, and very shortly it got leaked by Dr. Poirier to the press, and we got absolutely deluged by the press for weeks on end, on all hours of the day and night, from CNN on down, as to doing almost everything but offering us bribes to leak them some information. Well, from that, particularly their lab is suffering from the burn child syndrome, and they're basically telling the press, we've got it on hold. It is not quite on hold, but what I can tell you without leaking it to the press right now. If it had turned out to be cow hair or human hair, they would have found that out after the first 2 weeks and would have shipped the whole thing back with lock, stock, and barrel. The fact that that has not happened, you can draw your own conclusions on. Yes?
Fahrenbach, is there any speculation that if you've got an unknown DNA sequence, you know for sure it's not human, and you know this unknown sequence, that you can postulate a specific physical form from that sequence?
Not physical form, but you can postulate distance of relationship to chimpanzee, bonobo, gorilla, man, and draw diagrams as to the distance of the relationship. That's how we know that, for example, we are probably more closely related to bonobos than regular chimpanzees. That sort of thing. Yes?
Is it true that they use the Sasquatch hair as control in the new rationalization technique for that?
As control?
That's what I was told, and I didn't understand how they would use that as control.
No, the DNA sequencing is done in a way independently of controls. That is, you generate a DNA sequence of an unknown, and then by computer you compare it to existing sequences out of the same realm of the genome. Now this is the mitochondrial genome. It's a circular DNA molecule, and there are certain sets of genes that fit into this, and they're fairly universal for a very wide spectrum of animals, especially mammals, and most especially for primates. So provided you can pick out a specific gene or no gene fragment and amplify that, and the amplification is of course a problem, you can get as if it were a long sentence out of it, of the DNA encoding, and that sentence then, even though it's nonsense syllables, gets by computer searching compared to closely related species to match it up and see where there have been substitutions of bases or deletions or insertions or what have you.
So the people at Ohio State are actually interested then in finding out whether this unknown is phylogenetically related to known.
Oh, of course, yes. If the result comes out, it won't be just a bland statement, yeah, it's different. No, our hope is that we'll be able to say something intelligent about its relationship.
The hairs that were collected in the Blue Mountains, were they touched by human hands?
That doesn't matter. You simply clean them off because they...
So it doesn't contaminate the...
No, because you're dealing with cells that from human hands you have cuticular cells that come off and would adhere to the hair. But even for, let's say, microscopy, you would sonicate the hair in a detergent, and it just cleans off all the dirt. It comes out spanking clean. The contamination is not apt to come from the hair, but from possible other sources that are simply related to the technical difficulty of processing it in the lab, and the fact that they have to be extremely careful that there's not a little bit of hair dandruff that falls into their solutions. You had a question.
No, I just was going to point out that with a specific sequence, not only can you get distances, but you can examine for shared derived traits that will link that sample to its sibling taxon, so the taxon will share the last common ancestor.
Right. That's of course what you're aiming for, to see if it's derived from, let's say, Australopithecus or Dryopithecus or what have you, or the aardvark. Yes.
There's a lot of speculation about what Sasquatch is, and everybody seems to assume that it's, quote, not human, but if these hairs, I mean, if the Sasquatch is possibly anywhere near human, the genetic differences in human hair alone, the Sasquatch hair could possibly show up as human, or a human variety.
Well, no, because you're dealing with mitochondrial DNA. We're not dealing with with Simpson-type nuclear DNA, where you're worried about these subtle differences from this blood spot to that blood spot in the backs. Mitochondrial DNA is inherently very conservative. It is highly conserved. Within a species, there might be subtle differences that you might be able to delineate the race differences within a large species. But other than that, you can you can extract a lot of information about relationships by these subtle changes. Furthermore, the genes that are contained in the mitochondrial DNA, for many loci, the mutation rate per 100,000 years is sort of known, or per 10,000 years. So if you know that a given region has changed so and so much compared to man or to gorilla, you can speculate about how many hundreds of thousands or millions of years back the two diverged from each other.
I know that. I'm aware of all of that stuff. But what I'm saying is everybody's assuming that Sasquatch is, quote, not human.
Well,
that may not be true.
Well, it doesn't have much of a brain for starters. It doesn't use tools. It doesn't speak. So, you know, it takes a little bit more than watching TV
No one knows
to
that
be
Sasquatch doesn't speak.
What's that?
No one knows that Sasquatch does not speak.
Well, you ought to take my course. There are very good recordings. Incidentally, that recording by Barry just has come out in totally cleaned up form on a CD, and it's a rather remarkable recording.
One final question, and then we'll break for lunch.
Thank God.
Yeah, Dr. Thurman, I'm sorry.
You had a question there?
I just have a real quick one. Okay. So
can
they
say
find this hair to be, distinctive from such and such, and there's an unknown primate species.
I know what's coming. Go on.
So what? What does that do to the community? What does that?
Right.
Does that
We think about that. I mean, we make lots of milkmaid calculations way ahead of time. For one thing, you can't release that information to the National Enquirer, or the community is going to be the same as before. So our intention is that we have to work out the DNA sequencing, presumably to the bitter end as far as it can go, at as many bases and as many gene fragments as can be sequenced, and then submit it to the most high-profile journal that we can aspire to, regardless of the difficulty of getting it past peer review, where they probably want to do the whole thing over themselves with the raw air to start with. And if it gets published, then let the journal issue the press release, so it hits all levels of the press with one fell swoop and not just trickle through the Sun Times.
We're going to take a break. Okay, this is the last question, and we'll take a break for lunch. I'm sure people
That's right.
Go ahead.
These streets that were twisted off, what was the diameter of those streets?
The small one, which I own incidentally now, was 2.5 inches, and the large one was 3.5 inches.
And how high up off the ground was it?
Just 5 feet off the ground or so. Incidentally, in case people wonder about, you hear it, that this is just hoaxed with a pipe wrench on it. I've made experiments. My father is an engineer, and we have tried with suitable branches to twist them like that. It is impossible to do it with ordinary tools that are available. My father is in the process of developing a very elaborate locking hand that is lined with timing belts and stuff like that, that grips the tree to twist it. The little broken off piece that I have, you can see the hand grips on both sides. The bark is sort of polished. It got twisted like that, only about this far apart, so there wasn't a matter of, that kind of thing. Very close together and almost, 180 or more degree twist in it, very sharply spiral. The hand prints on it were still smelling when Bill Lowry brought it home and let his wife smell it. She could still smell it. And There's still one hair on it, by the way.
Then you don't recommend wrestling with one of these creatures?
I don't think that'd be inclined to do so.
Why would they break off a tree limb?
Good question. That you want me coming into a Sasquatch ethology. It might be a territorial device that, in that case, it would be only the males that would be doing it. Now, if anybody has information, the Patterson female didn't twist off any trees that we know of. So if it's males, it might very well be a territorial device. Sometimes, apparently, they rip up stuff too, like gorillas who would throw it on the ground and defecate on it and this sort of thing. So there's no reason to assume that they don't have territorial marking devices. All the other primates do. All the other primates do all sorts of other things. So just because we don't see it doesn't mean they don't do it. We don't see them play with their babies. We don't see a lot of things that they undoubtedly do and that all primates do.
We're going to take a lunch break now. We'll convene back here at 2:30. Directly outside, they have a Bigfoot paraphernalia sale going on by Cullen Murphy. I encourage you to take a look. 2:30 here.
If you're enjoying all this rare and unique content, please show your support by subscribing and leaving comments.